Farmers and ranchers constantly strike a balance between economic forces that can vary year to year and the welfare of the land that sustains us all far into the future.
My dad was probably one of the, as far as a steward of the land, he didn't have a lot of corn on corn. He had a lot of rotation with small grains and put clover in behind oats for green fertilizer, that type of thing. So I grew up with it.
In 1952, we started terracing and just did one field first, and then continued on until the whole farm was under a conservation practice.
The Wortman family has witnessed the evolution in conservation practices on their farm and in their district.
The terraces just held the water up, and we could tell, you know, on the yields that we were getting better yields by doing that.
Chris and Holly Wortman both work off the farm, but the prospect of passing it on to their daughters is important to them. This family farm is a testament to the monumental changes in farm practices in the last 40 years.
I just see that as just in the last, 20 years, 25 years since I was helping out here as a kid. So it's changed immensely.
We farmed with mostly 2-row equipment, and when we quit, we were doing 4-row. I was out at Husker harvest days. They had a 48-row corn planter out there. You know, most of my fields, you wouldn't have been able to turn around with it. They're so huge.
The management approach to farming, I think, is more difficult today than it was 50 years ago because we're dealing with such tighter margins. We're dealing with more money. So if you're not a sharp manager, sooner or later, it's going to catch up with you.
The margins have also tightened in terms of groundwater quantity and quality. Those factors have driven innovation as much as the economics of agriculture.
Post-World War II, when commercial fertilizers really came available, they were cheap.
A lot of guys poured it on. If a little is good, a lot is better, type mentality.
Nitrogen fertilizer and herbicides delivered on their promise of increased, reliable yields. Heavy tilling coupled with chemical application were the preferred methods for weed control and crop production.
There were contests to see who could make it the blackest because you didn't want anything on the top of the ground, and which was just 100% wrong thing to do. But that was the way it was farmed for years and years.
What was lost in that was the value of the crop residue, or stubble, that helps prevent wind erosion and puts nutrients back into the soil. The timing and amount of water used are also key.
If we have high rates of recharge on the land and we over-irrigate, we're running that water past the root zone. If we have over-fertilized or the plants haven't used nitrogen, it's flushing that nitrogen down into what we call the vadose zone, which is between the bottom of the root zone and the top of the aquifer.
And once they're below the root zone, the only way they're coming back is through pumping that groundwater and bringing them back to the surface to be used.
We realized some of the things, our practices back in the 60s and early 70s were not the best management practices that were out there. And it created some problems for the next generation to try to correct.
In northeast Nebraska, the Bazille Groundwater Management Project is a multi-partner collaboration working to address nitrate problems.
It's in an area that's part of 4 NRDs, Upper Elkhorn and Lower Elkhorn and the Lower Niobrara and Lewis and Clark. The Bazille Creek drains the whole area. We've known for the last 20 years that there's been a nitrate contamination problem in that area. We've kind of leveled off, but it's still there, and we can't turn the corner to where we get groundwater clean again.
With that cooperative effort, we're hoping that in years to come we can get the nitrogen to be lowered and get the producers in this area to also understand they're a part of the solution to this problem.
We learn something every day, that's for sure.
Dave Condon has worked with the Upper Elkhorn NRD over the years to implement best management practices on his farm outside of Creighton.
We started out with doing a little no-till on some of our dry land ground that was maybe tougher ground that I would say, and that was probably 8 to 10 years ago we started doing that. We've just progressed a little bit each year, and this year I was 100% no-till on all my acres.
The NRDs offer training and education in conservation practices, cost-share programs, and incentives to help ag producers invest in improvements and new technologies.
When trying something new, cost share usually attracts people.
A lot of folks, when they're done with harvest, can actually seed a cover crop, another growing crop on top of the residue.
Turnips, tillage radishes, and Australian winter peas. Learning how cover crops can hold up nitrates or produce nitrates that you don't have to put it out there yourself, and probably more stable nitrates. So that caught my interest. That's a radish.
The farmers are doing a great job, we think. You know, even with the economics of the commodity prices right now, they have to very closely manage their applications of irrigation water, their fertilizer applications.
And then the wheat came back on its own. A lot of it would be bottom line too, of if I can produce nitrates myself and not buy them and haul them out there, that really caught my interest.
Should be out doing something else, but you know, I'm learning along with you guys. So
This year we cooperated with purchasing the Optrix unit.
He's always looking for ways to utilize that nitrogen fertilizer the best, and so we just jumped on board with him. You know, he wanted to try this out, and so we said, you know, we'll help you out with that.
This technology analyzes soil characteristics to optimize nitrogen application.
what we're doing is we're looking at the color of the corn as we move through the field. A greener color would indicate a healthier plant. This is just continuously looking at plants and adjusting the rate that this unit is putting out on the corn.
They're concerned about water quality, you know, and they want to do what they can to help, but it's got to be something that, you know, will keep farming profitable, but also help with the environment.
Mostly they've been real willing on it. I'm not sure that we've reached all of them yet. And that's why we're doing a concentrated effort with the 4 NRDs. Hopefully we can get to a point where the problem is reversed.
Education and cost-share programs have helped ag producers become more efficient in their resource management than ever before. Still, in communities across the state, natural resources districts are dealing with the legacy of farming practices of the past century.
In 1987, the district approved, it was the very first groundwater management plan in Nebraska for quality.
The EPA has set limits on maximum contaminant levels for safe drinking water. MCLs are measured in milligrams per liter or parts per million. The MCL for nitrates is 10 parts per million. When nitrate levels approach or exceed safe limits, the NRDs implement a 4-phase regulatory structure. Under each phase designation, increasing regulations apply.
We do have a large area of our district that's in a phase 2 and phase 3 area. We require them to do soil samples, water samples, and write down their expected crop yields and what their actual crop yield was.
Then they can calculate how much they have in the soil that is present for the next crop, and then how much do they need to add to that to get the yield goal that they're really shooting for.
It's an educational process is what it is to make them realize that there is a recommendation out there of how much nitrogen should be applied to a crop, and we just want them to be aware of it before they make that decision.
The first line of groundwater defense is education, and those efforts in the Central Platte District are slowly paying off.
I know going from nearly 20 parts per million to 14 parts per million from 1987 to 2015 doesn't seem like a lot, but when you figure that we started applying nitrogen in this area probably in the 30s and 40s, we didn't get to where we were overnight.
It may have taken 20 years to have that nitrogen move into the system. It may take 40 years for it to get it completely out of the system.